Hello, good morning, good evening, everyone. Could you please confirm once that you can see me, you can hear me, as well as you can see the presentation? Okay, thank you. Okay, thank you so much. We shall just begin in a few minutes. Okay, we shall start. Yeah. Okay, let us start. Everything is all right. We shall begin. So, very good evening, everyone. My name is Ambuj. I am a research scholar at Agriculture and Food Engineering Department, IIT Kharagpur, and I will be taking your live interactive session for the course Data Analytics with Python. This course is taught by Professor A. Ramesh from IIT Roorkee. And what you'll be doing in this particular session, I'll be sharing some of the objective type of questions based on the previous week's content in front of you all. Okay. So these are the questions based on our previous week's content. Okay, objective questions, all are objective 10 questions. Will be solving, and after the solution is over, I shall be walking you through two Google Colab notebooks. Okay, that I have prepared in order to demonstrate you some of the hands-on skills for this particular course, that is data analytics with Python. Okay, so this is the agenda for this particular meeting. Let us begin. Okay. So please do try to answer the questions which I am posting in front of you. Okay, the very first question is this one. In the analysis of variance procedure, ANOVA, okay, the term factor refers to dependent variable, independent variable, different levels of treatment, or the critical value F. Okay, it is not a hard and fast rule that you have to be just correct in the very first attempt. Okay, just try to give your opinions. Okay, thereby you will get a better idea. Okay, okay, the person is saying B. Okay, shall minimize this screen. Yeah, good. B, then B, good. Great. B, good. Very simple question is there. Analysis of variance procedure ANOVA. The term factor refers to dependent variable, independent variable, or different levels of treatment. Okay, this is the call. B. Okay. Yes, now you try to see. Indeed, the correct option is B, the independent variable. Okay. Most of you have answered it correctly. Okay. In the analysis of variance, okay, or in short, it is known as ANOVA. Factor is explanatory or the predictor variable whose effect on the response variable is being studied. Okay. Dependent variable is what we tend to measure, and the factor is the independent variable that defines the groups. Okay. Different categories within a factor are known as levels. For example, the treatment which you have given A, B, or C. Okay. If we compare crop yields under three different fertilizer types, yield is the dependent variable. Okay. Fertilizer type is the factor, and three types of fertilizers are the levels of factor. Okay. If we, for example, if we are trying to compare the yield, okay, we are trying to compare the yield, crop yield under three different fertilizer types. Okay. Yield would be the dependent variable. Okay. And your fertilizer type will be the factor, and the three fertilizer types, they would be the levels of factor. Based on this example also, you can cast your own examples in order to understand this question very particularly. Okay. Meanwhile, through the second system, I am trying to admit some of your fellow students. Okay, that is the thing. Yeah. So this is clear. The other options are the dependent variable, the independent variable, levels of treatment, and your critical value F. Okay. So dependent variable will be incorrect. Independent variable will be correct. Okay. Different levels of treatment will be also be incorrect. The critical value of F will also be incorrect. Okay. So the correct option is the B, that is your independent variable. Okay. This is the thing. Okay. Let us move forward. Okay. With the discussion. In a problem of ANOVA involving three treatments and 10 observations per treatment, SSEE. SSE is equal to 500. What is the MSE for this situation? Okay. This is the question which is being asked. Try to calculate whether it is 130.2, whether it is 48.8, 18.52, or 30.0. You know the concept very easily, you can solve it. Okay. Two people are saying C, three, four, five. Okay. All are saying C. Good. Okay. Yes, indeed, you try to see here. The correct option would be C only. Okay. In your one-way ANOVA, your MSE is SSE over DF error, which is degree of freedoms for error. Okay. So you are having three. treatments, 10 observations per treatment. So n will be equal to 3 times 10, that is 30. Degree of freedoms for error will be n minus k. That is 30 minus 3 treatments. K is 3 here. K is the number of treatments. So 30 minus 3 is 27. And MSE is nothing but SSE over DF error. Okay. So that degree of freedom for error you have just calculated, which is 27. Okay. So directly you will put the values here in this particular notation. SSE is given in the question as 500. DF error you have calculated as 27. So SSE over DF error, that is 500 over 27, that is 18.52. Okay. So this is the thing. Let's move forward. The F ratio in a company completely randomized ANOVA is the ratio of the F ratio in a completely randomized ANOVA is the ratio of, okay, B, good. Do try to solve. The F ratio in a completely randomized ANOVA is the ratio of, you are given MST over MSC, MSTR over MSC, MSC over MSTR, and MSC over MST. Okay. Options have been given here in short. It would have been much simpler if the options would have been given as a full form. Okay. But still you would be in a position to solve this only if you know the concept. Okay. Very good evening, Sukumar. The F ratio in a completely randomized ANOVA is the ratio of MST over MSC, MSTR over MSC, or MSC over MSTR, or MSC over MST. Okay, this is the question. Others, please try to give your opinions. Okay, my voice is not audible. Is it with you or with everyone? If it is with everyone, I'll rejoin. If it is with you only, then you should rejoin. What is the case? Voice is not audible. Okay, okay. I will rejoin then. Just a second. Yes, can you hear me now? Is it better? Is it worse? Or yes, you can hear me? I think it would be clear only, right? Can we continue? Okay, 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 okay. We shall continue. Okay, okay, great. We shall continue. The F ratio in a completely randomized ANOVA is the ratio of MST over MSC or MSTR over MSC or MSC over MSTR or MSC over MST. Okay, this is the question, okay, which is being asked in this particular question. Okay, just 1 second. Okay, yes, I was here. Yeah, see here, the F ratio in a completely randomized ANOVA is the ratio of MSTR over MSC. Okay, so in a completely randomized ANOVA, F statistic is defined as F equal to mean square for treatments divided by mean square for error. Okay, MSTR is mean square for treatments, MSC is mean square error within the group variation. Okay, so F is directly given as MSTR over MSC. Okay, so second option will be only correct. Okay, MSTR over MSC. No other option will be correct. Okay, MST over MSC, MSTR over MSC, as well as your other option was MSC over MSTR or MSC over MST. These all options are not correct. Okay, the only correct option would be your MSTR over MSC. Okay, this you try to keep a note of it. Okay, during our video lecture, sir has tried to clearly explain this. Okay, so you can go through it if you are having any issues. Rest is very, very clear. Okay, F statistic will be nothing but mean square for treatments divided by mean square for error. That in short we have written as MSTR over MSC. Okay, this is the thing. Now you try to see this particular question. An ANOVA procedure is applied to data obtained from 7 samples where each sample contains 10 observations. Okay, an an ANOVA procedure is applied to data obtained from 7 samples where each sample contains 10 observations. Okay, the degrees of freedom for the critical value of F are 7 numerator and 20 denominator degrees of freedom, or is it 5 numerator and 20 degrees of freedom, 6 numerator and 63 degrees of freedom, and 7 numerator and 63 denominator degrees of freedom. Okay, so numerator degrees of freedom and denominator degrees of freedom you try to calculate for your ANOVA. Okay, with 7 samples where each sample contains 10 observations, and the degrees of freedom for your critical value of F would be what? Okay, this you try to calculate. Okay, Yes, you have not attended previous sessions. There is a recording available for that. I'll just provide you the link for that. Okay. Wait, you try to attend this particular session. Okay. And each and every session is recorded. So I'll try to provide you the lecture recording. Okay, along with the notes link at the last. Okay, you try to remind me. Okay. Since the voice and video and it is echoing now for all. Is my voice clear? Not clear? Please tell me. More than one opinions would be necessary. It is clear. Okay. According to me also, it is clear. Okay, okay. Then for the person for which it is echoing, please try to reconnect. Okay. Jaypreeta. You try to reconnect because for all of us, it is clear. Okay. Mostly clear. Then you please try to reconnect. And for the person who was having the doubt, that recording is available. Yes, each and every session is recorded. So I'll try to provide you the recording. Okay. Try to provide you the recording as the session is over. Just remind me. I'll try to give you the link. Okay. With the link, you can join. Okay. That is the thing. Notes are also provided as well as your YouTube video recordings. Both are provided. Okay. And ANOVA procedure is applied to data obtained from 7 samples, where each sample contains 10 observations. Okay. The degrees of freedom for the critical value of f are 7 numerator, 20 denominator, 5 numerator, 20 denominator, 6 numerator, 63 denominator, 7 numerator, 63 denominator. What is the thing? No? Yes, the correct option would be 6 numerator and 63 denominator of freedom, degrees of freedom. Okay, 6 would be numerator, 63 would be denominator. Okay, now you try to see for your one-way ANOVA, your degrees of freedom for numerator would be k minus 1, and degrees of freedom for denominator would be n minus k, where k is the number of samples, n is the total number of observations. So number of 7, your voice seems to be breaking intermittently. Okay, I will try to fix that. Now it should be more clear, more bandwidth would be given to audio as compared to video. So is it fine now, or I shall search for some other procedure? Confirm once. Is my voice clear now? Not clear? It is clear? Good, good. Yes, I just switched off the video so that more bandwidth would be available for the audio. Okay, so yes. Now you try to see for your one-way ANOVA, degrees of freedom for numerator is k minus 1, degrees of freedom for denominator is n minus k, where k is the number of samples, n is the total number of observations. So your number of samples is k equal to 7. Observations per sample is 10. So n is 7 into 10, that is 70. Okay. So now you try to compute the degrees of freedom. Numerator degrees of freedom would be k minus 1. Okay. K minus 1 means 7 minus 1. Okay. 7 minus 1 meaning is 6. And degrees of freedom for denominator would be n minus k, that is 70 minus 7, that is 63. Okay. That would be the thing. Let me admit some of the people. Just 1 second. Yeah. So you're for one-way ANOVA. Okay, degrees of freedom for numerator we have directly calculated as k minus 1. K is your number of samples. Number of samples has been given as 7. So 7 minus 1 would be equal to 6. Okay. And number of degrees of freedom for denominator would be n minus k. Okay. So n here is total number of observations, that is 7 times 70, that is 70. 70 minus k. Okay. K was 7. So 70 minus 7 is 63. Okay. So in total, most of you have answered it correctly. The correct option would be 63 only. Okay. That is the thing here. Just one second. Some person wants to join. Not join. Okay. No problem. This is the thing. Okay. So it's an easy question. Not much complication is there. Okay. Yes. We shall move forward. Okay. And then ANOVA problem, if SST equal to 200 and SSTR equal to 80, then SSE is. Okay, 280, 120, 80 or 120. Okay, try to solve. Everything has been given in short, but if you know the concept, very easily you would be able to solve the question. Okay. Already we have solved one such example. Okay, so do try to solve this one also. Okay, B, B. Okay, B. Good. In an ANOVA problem, if SST is 200, SSTR is 80, SSE is. Okay, this you have to answer. 200 minus 80 equal to 120. Okay, good. Value of SSC is 120. Good. Very few people are responsive. Why so? A lot of students have joined. Others also try to think in this form and manner. Now week 5 is there. Okay. Not much time is left for the examination. So study properly all the concepts. Try to be maximum responsive in the live interactive sessions which we are holding. Okay. That is for your own good, for your own benefit. Okay. To try to solve. Yes, now you try to see here. Most of you have answered it correctly. I'm very happy. You know the concept. Means you have gone through the lectures which we have presented. Okay. It is 120 only. Okay. In your one way ANOVA, fundamental identity is this one. SST is SSTR plus SSE. SST is total sum of squares. SSTR is sum of squares for treatments. SSE is sum of squares for error. SST has been given to you as 200. SSTR has been given to you as 80. Now you have to compute SSE. Okay. So SSE will be equal to SST minus SSTR. Okay. SSE will be equal to 20 minus 80, that is 120. Okay. This is very clear here. No further confusion is there. SST, if you try to understand, it is the total sum of squares. Okay. It will measure the total variability in response variable. Okay. So SST is summation Yij minus Y bar whole square. Okay. Yij's are the individual observations and Y bar is the mean. Okay. Mean of all observations. SSTR is nothing but your sum of squares for treatments. Okay. What it will measure? It will measure the variability due to differences between groups, means. Okay. So SSTR is summation Ni Yi minus Y bar whole square, where Yi is mean of group I and Ni is number of observations in group I. Okay. Interpretation is variation explained by the factor, uh, that is the treatment effect. Okay. SSE is sum of squares for error. That is also this one only. Okay. It measures the variability within each group. So SSE will be summation Yi minus Yj Yi bar whole square. Same formula. No further confusion is there. Okay. Then the fundamental relationship which we have established is SST equal to SSTR plus SSE. That is the total variation. It is explained variation plus unexplained variation. Okay. So conceptual summary is like this. The overall variability is SSTR, that is the variation due to treatment, that is the signal, and SSE is random variation, which is the noise. Okay. So F will be ANOVA will be directly essentially comparing your signal to the noise using MSTR over MSC. Okay. So difference between group variation is relatively large to within group variation, then the statistic will be large, suggesting significant treatment differences. Okay. This one is the entire thing. Okay. The critical F value with 8 numerator and 29 denominator degrees of freedom at alpha equal to 0.01 is 2.18, 3.20, 3.53 or 3.94. To try to solve it, if you are having F table, directly you have to look the values in the F table. Okay. No further delay or confusion is there regarding, sir, how I will do it. If you are not having F table, then be patient. I'll provide you the F table along with the requisite answer also. Okay. To try to solve, give your opinions. Critical F value with 8 numerator, 29 degrees of freedom at alpha equal to 0.01 is okay. 3.53. Good. 3.53. 3.53. Good. Jbasti has written the critical F value for is obtained from the F distribution table for 8 numerator degrees of freedom and 29 denominator degrees of freedom at alpha equal to 0.01. From the table, the critical value is 3.53. Therefore, the correct option is 3.53. Option C. Good. See, I agree with most of you. I don't know who has prevailed this confusion. This was there in my mind also, but directly nothing much complicated is there. Here, C, the correct option would be 3.20. Most of you have answered it C. Okay, I will explain you. Try to see here why it would be 3.20. For the first time, I also got confused. Okay, then I went to the F table. See, my sincere request to you all is join at the beginning for the maximum benefit. Okay, I am allowing you to admit even at the last moment, but it won't be giving you the type of benefit which you want to avail from the session. Okay, so please join the session in the starting itself. Okay, that will give you maximum clarity. Now you try to see this is the F table. Okay, F distribution table I have presented here. Okay, try to see here. Here you try to see where my cursor is moving. It is for different alphas. Okay, for different values of alpha, the denominator degree of freedom and numerator degree of freedom both have been given here. Okay, degrees of freedom in numerator, that is denoted by DFN, that you have to see here where my cursor is pointing. DFD is degrees of freedom in denominator. Okay, so that you we have to see here. Okay, and for different alpha, alpha equal to 0.005, alpha equal to 0.01, alpha equal to 0.025. Okay, then alpha equal to 0.05, then alpha equal to zero point 0.1. For all these degrees of freedom, this is the F distribution table which I will provide you along with the uh, fold in the that particular folder only. Okay, what happened? Voice is still not clear. Yeah, this I'll just provide you in the that particular PDF folder only. Okay, in which I am providing you all the requisite notes. Okay, in that particular, yeah, in that particular folder only, I'll try to give you the all the notes. Okay, voice is breaking, so can't deal with anything, can't do anything right now. I am at a very remote location. That is why it must be breaking. Screen is not visible. I don't think so. I think you can see what I can see. Screen is visible as far as I can see. I am trying to admit people also. They are getting admitted. Voice can break, so please bear with it. I can't do anything because I am at a very remote location. I turned off the video so you can hear me properly. But if it still is breaking, then please bear with it. Try to go through the recording. It is still breaking, then I will rejoin. I'll try to explain you once again. If it is clear now, then please tell me, I'll continue. Clear, not clear? Anything, any response? Yeah, I'll explain it once again. There is no problem. But if my voice is clear, now it is clear right now. Okay, okay. Okay. Actually, it is breaking in between. It is not continuously breaking, it is breaking in between. I'll explain you once again. Okay. This is the F table. Okay. This is the F distribution table. Okay. Which you have to, in which you have to look for the different values, F values. Okay. For different alpha, the tables have been made here. Okay. Alpha equal to 0.005, alpha equal to 0.01, alpha equal to 0.025, alpha equal to zero point zero 0.05, then alpha equal to zero point 0.1. These tables are there. Okay. Now you try to see here DFNA is degrees of freedom in numerator. DFD is degrees of freedom in denominator. Okay. So DFN here you have to see 1, 2, 3, 4, 5, 6 where my cursor is moving. Okay, that is degrees of freedom for numerator, and DFD is degrees of freedom in denominator. Okay. So there directly you have to see, and while seeing, you just have to check for the value of what is the F value. Okay, that you have to see. Now you try to see here. Question was asking us to find out the value of 8 numerator and 29 degrees of freedom. Okay, at alpha equal to zero point zero 0.01. So first of all, I will see alpha equal to zero point zero 0.01. At alpha equal to zero point zero 0.01, when I am seeing, then numerator degree of freedom, what it should be? It should be 8. Okay, so 8 numerator degree of freedom I am seeing here. And denominator degree of freedom, how much it should be? It should be 29. So at 8 and 29, directly I am seeing the value as 3.20. Okay, so directly I have marked my answer as 3.20. Okay, that is the thing. That is the screenshot or the snapshot window I have posted here. Correct option would be 3.20. It won't be 3.53. Okay. Alpha is 0.01. Yes, for alpha equal to zero point zero 0.01 only. See here, alpha is 0.01 only. At alpha equal to zero point zero 0.01 for 8 numerator degrees of freedom, and for 29 denominator degrees of freedom, see here the value is 29. These one, the rows corresponding to this particular uh, denomination is your denominator degrees of freedom, and your columns are of numerator degrees of freedom. Okay. If alpha is 0.05, okay, I will find out if alpha is 0.05. If alpha is 0.05, and for your 8 and 29 combination, I am getting the value as 2.28. Okay, see here, if alpha is 0.05, and for, what happened? Yes. You are asking about if alpha equal to 0.05. Okay. If alpha is 0.05, then for 8 degrees of freedom of numerator and 29 degrees of freedom of denominator, the value would be 2.28. Okay. But alpha value is given in 0.01 in the question. Yes. Okay. It is given 0.01 in the question. Definitely. Okay. It is 0.01. See, 8 are the degrees of freedom in the numerator. 29 are the degrees of freedom in the denominator. Directly value is coming as 3.20. And what you were looking is this 3.53. Okay. It is corresponding to 6 degrees of freedom of numerator and 28 degrees of freedom of denominator when your alpha is 0.01. Okay. I hope I am clear. Okay. If any further confusion is there, then feel free to ask me. Okay. Rest we will continue. Now it is clear? Okay. There is nothing much difficult here. Okay. Alpha, according to the alpha value, okay, we have been provided the F value directly in the F table. Okay. What we just have to do, we just have to find out that particular value and tell that what is that particular value. Okay. So no further confusion is there. Okay. I hope so. I'm pretty clear. See here. Once again, I am telling you, or last time, if anybody is having any confusion, feel free to ask me. Can explain you a number of times, no problem. Okay. See, we have been asked the critical value with 8 numerator and 29 denominator degrees of freedom. Your alpha value is 0.01. So directly I have gone to the F table. I'll provide you this entire table. Don't worry. Okay. You don't have to memorize it directly. If in the examination the question is like this, either F table would be provided to you or the value would be directly given to you. Value won't be given, otherwise question can't be found. So you will be provided F table. Don't worry about it. Okay. So question was asking me to find out for alpha equal to 0.01. So for different alphas, this is the table, F distribution table. So 0.005, this one is the table. 0.01, this one is the table. Then 0.025, then 0.05, then zero point 0.1. Okay, this one is the table. So for 0.01, okay, for 0.01 with 8 numerator and 29 degrees of freedom. So numerator degrees of freedom are these one, okay, which I am currently highlighting. These one are the numerator degrees of freedom. Okay, these ones. So 8 I have seen here and 29 was the denominator. So for 8 and 29, this one is the value. Okay, this one is the value. For 8 and 29, you see here 3.20 will be the value. Okay, this is the thing. Okay, now I hope so. Everything is clear to you all. Okay, no much confusion is there. Okay, if still anything is there, feel free to ask me. Okay, rest we can continue. Critical F value with 8 numerator and 29 degrees of freedom is at alpha equal to zero point 0.01 is 3.20. Okay, then moving forward, two independent simple random samples are taken to test the difference between the means of two populations. Standard deviations are not known but are assumed to be equal. Sample sizes are n1 equal to 15, n2 equal to 35. Correct distribution to use is the T distribution with 51 degrees of freedom, Z distribution with 50 degrees of freedom, Z distribution with 49 degrees of freedom, or T distribution with 48 degrees of freedom. Okay, this you have to calculate. Try to find out. Most of the students try to be as responsive as possible. Okay. I know you might not be very correct at the very first attempt, but no issues. Okay. At least give your opinions. Try to provide what you think about this particular problem. Okay. Since the population standard deviations are not known and the samples are independent, we use the T distribution. Option number D. Good. D, because the population standard deviation are unknown. Okay, good. D option is correct because standard deviation are not known and independent. Okay, D. Good. The conflict is between D and C. D, D, D. Okay, D only. Okay, good. And that is also, please do try to communicate, try to give your opinions. What shall be the correct option? See, simple problem is there. Two independent, simple random samples are taken to test the difference between the means of two populations. Standard deviations are not known but are assumed to be equal. Sample sizes are n1 equal to 15, n2 equal to 35. Correct distribution to use is T distribution with 51 degrees of freedom, Z distribution with 50 degrees of freedom, Z distribution with 49 degrees of freedom, and T distribution with 48 degrees of freedom. Okay. Try to communicate your opinions. Okay. We'll see. What shall be the correct option? We will see. Okay. Yes, now you try to see here. It would be T distribution with 48 degrees of freedom only. Okay. Two sample t-test with equal variance assumed. Okay. Population SD are unknown. Variances are assumed equal. Samples are independent. We use the pooled t-test. Okay. Degrees of freedom formula is df equal to n1 plus n2 minus 2. It would be 15 plus 35 minus 2, that is 48. Okay. 15 plus 35 minus 2, that is 48. Okay. Okay. Why it is not Z? Because Z distribution is used only when population standard deviations are known or sample sizes are very large and sigma is known. So here sigma is unknown. We will use the T distribution. T distribution with 48 degrees of freedom. Okay. Try to provide you a general idea. Okay. General idea regarding the selection of statistical tests. Okay. In which situation you have to choose which type of test. Okay. That I will try to provide you. Okay. When your situation is like that, you are having one sample mean. Data type is continuous, sigma is known, sigma is unknown. You for sigma known, go for one sample Z test. For sigma unknown, you go for one sample T test. Okay. For your two independent means, if your data type is continuous, sigma 1, sigma 2 known, then you use two sample Z test. If sigma is unknown and equal variances are assumed, you go for pooled T test. Okay. If sigma is unknown and unequal variances are there, then you go for Wells test. Okay. This we have not covered it yet, but I'll try to cover it if the time permits. Okay. Then paired samples are given and your data type is continuous, then you go for paired t-test. Okay. If more than two means exist and data type is continuous, okay, and the conditions are independent groups, then you go for one way ANOVA. If two categorical variables are there, okay, and your data type is categorical and frequency data is there, then you go for chi-square test for independence. Other than that, if your situation is one categorical variable with a goodness of fit, okay, and your data type is categorical and conditions are observed versus expected frequencies, okay, then you try to use chi-square goodness of it. Okay. Rest, if your population proportion or is binary and your NP is greater than equal to 5 or N1 minus P is greater than equal to 5, you go for one proportion Z test. Okay. If difference between two proportions is binary and conditions are mostly large samples, go for two proportion Z test. Variation of one population is continuous, conditions are normal population, then you go for chi-square test. Okay. If you have to compare two variances and data type is continuous and conditions are given for normal population, you go for F test. Okay. If your relationship between two continuous variables is continuous and conditions are linear relationship, you go for linear regression or correlation test or your simple t-test for slope. Okay. This is in general what the criteria is about selection of different types of tests. Okay. Okay. In general, this is regarding the selection of different types of statistical tests. In which particular condition you will use which particular type of test. Okay. That is what is being written here. Okay. Then what is your quick decision logic or a summary? First of all, you have to see whether the response variable is continuous or categorical. If it is continuous, you go for mean-based tests, which are z-test, t-test, or ANOVA. If your data type is categorical, go for proportional test or chi-square test. Okay. If it is a one group, you go for one sample test, two sample test, and three or more than three groups, you go for ANOVA. Okay. Are samples paired? If they are paired, then go for paired t-test. If they are not paired, then go for independent sample test. Okay. Is sigma known? If it is known, you go for z-test. If it is not known, you go for t-test. Okay. That is the thing. Now you try to see summary feedback. Goal is to compare mean. You go for z-test, t-test, or ANOVA. If your goal is to compare proportions, go for z-test. If your goal is to compare frequencies, go for chi-square test. Your goal is to compare variances, go for F-test. If your goal is to study relationship, you go for regression or correlation. Okay, this is in general or in short different summary of different types of tests. Okay, as well as where you will use which type of test. Okay, it is the thing. Now we shall move forward to the next question. State true or false. Sampling distribution of two populations P1 minus P2, P1 bar minus P2 bar is approximated by a normal distribution, whether this statement is true or false. To try to communicate. True. Okay. False. True. False. Okay. Two trues and one false. Good. True because the sampling distribution of P1 minus P2 is approximately normal for large sample sizes. Okay. True. 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 Okay. Okay. True. True. Okay. True. Okay. True. Okay. See here it would be true only. Okay. Only one student was saying false. I have seen the responses. It would be true only, okay? Why so? Try to see here the sampling distribution of P1 bar minus P2 bar, okay, is approximated by a normal distribution. That information is given in the question. Okay, statement has been given mentioned in the question. Okay, if you try to see here, P1 cap minus P2 cap, okay, or P1 bar minus P2 bar, that is x1 over n1 or x2 over n2, where each sample proportion comes from a binomial distribution. Why is it becoming normal? That is the question. Because a binomial distribution becomes approximately normal when the sample size is large. This is due to CLT, that is central limit theorem. If P1 bar or P bar is approximately normal if NP is greater than equal to 5 or N1 minus P is greater than equal to 5. It already I have provided this particular information right in this session only in the summary table. Okay. So your when both the proportions are approximately normal, their differences is also normal. Okay. So since the difference of normal variables is normal. Okay. So it will try to follow a normal distribution. Okay. Mean and standard error. Mean is uh, P1 minus P2, P1 bar minus P2 bar. Okay. Estimated value of that. Standard error is this one. P1, 1 minus P1 divided by N1 plus P2, 1 minus P2 divided by N2. Since approximation is holding when N1, P1 is greater than equal to 5 and N1, 1 minus P1 is greater than equal to 5. Then 2 P2 is greater than equal to 5 and 2 1 minus P2 is greater than equal to 5. If the samples are small, this distribution is not well approximated by normal. So final conclusion is true only. Okay, statement is true provided the sample size are sufficiently large for us to apply the normal approximation. Okay, in that particular case only the condition would be true. In rest all the uh, cases statement will not be true. Okay, this is the thing. Okay. That is the thing here. See here, let us move to the next question, ninth question, which is mean marks obtained by male and female students of school ABCD in first unit test are shown as below. Okay, sample size, sample mean marks, population variance for male and female has been given to you. What is the standard error between two means? Standard error between two means you have to calculate. Okay, to try to calculate it. The standard error for the difference between two for the standard error for the difference between two means is 2. Okay, option D. Okay, good. Rest of the students do try to calculate it. Okay. D because uh, quantifies the sampling error difference between two means. Okay, good. Only two responses. Why so? Others also to try to calculate. Okay. Standard error for the difference between two means. Okay. To try to calculate. Mean marks obtained by male and female students of school ABCD in first unit test are no, shown below. Okay. Male and female sample size and sample mean marks have been provided to you along with the population variance. What is the standard error for the difference between two means? See here, the correct option would be 2 only. Okay. 2.0, that is D. See here, you have been given sample size. Denomination is N. Okay. N is 64 and 36. Sample mean marks is 44 and 41. Okay. X bar is 44 and 41. Population variance denomination is sigma square. We will take that only 128 and 72. So standard error is sigma square, sigma 1 square divided by n1 plus sigma 2 square divided by n2. Okay. So standard error would be under root of sigma 1 square divided by n1 plus sigma 2 square divided by n2 whole over under root. Okay. So sigma 1 square divided by n1, that is 128, okay, divided by 64, plus sigma 2 square, that is 72 divided by 36. Okay. 64, 128 is 2 times. Okay. It will get cancelled here. Here and here it will get cancelled. It will come as 2. Okay. And 36, same for 36 and 72. Okay. It will be also coming as 2. Okay. So 2 plus 2 is 4 and the root of 4 is 2. Okay. Standard value, standard error value directly will get us 2. Okay. This you try to keep a note of it. Okay. The standard error for the difference between two means would be 2, 2.0. Okay. D. That is the thing here. Now you try to see if you are interested in testing whether or not the average marks of males is significantly greater than that of females. What is the test statistic? That value you have to provide. First of all, your test statistic calculation should be correct. Then you should provide the value. Okay. Just 1 second. If you are interested in testing whether or not the average marks of males is significantly greater than that of females, the test statistic is whether it is 2.0, whether it is 1.5, 1.96, or 1.645. I would try to calculate. Okay, it is B. Okay, let me go through it. Yes, it is B only, 1.5. Okay. So from your question number 9, your x1 bar goes 44. Okay. For male, it is 44. For female, it is 41. Okay, 44 and 41. Yes. Directly from the table, I am able to see here 44 and 41. Okay, directly I am able to see here 44 and 41. Okay, so these are the different values of sample mean marks. Okay, 44 and 41. Okay, now you try to see here from question number 9 directly I have noted the values. X1 bar is 44, X2 bar is 41, standard error is 2.0 that I have calculated in question number 9. Now I have to test this particular hypothesis whether mu1 is less than equal to mu2 or mu1 is greater than mu2. Okay, this is a rat-tailed jet test. Test statistic formula is this one. Okay, x1 bar minus x2 bar divided by standard error. X1 bar is 44, x2 bar is 41. Okay, standard error is 2. Okay, 44 minus 41 is 3. Okay, 3 by 2 is 1.5. Correct option would be 1.5. Okay, that is the thing. I hope so that I am clear. Okay, if still any doubt is there, feel free to ask. Okay, explain again. Okay, I'll explain. See here from question number 9, we are having these values of x1 bar. X1 bar is 44, x2 bar is 41. Okay, these are values which we are having from question number 9. Sample mean marks. Sample mean marks are 44 and 41. That we are having from question number 9. Okay. So from question number 9, if I am having x1 bar as 44, x2 bar is 41, standard error value directly I have calculated in my previous question as 2. Okay. This value I have calculated. So standard error is 2.0. Okay. X1 bar is 44, x2 bar is 41. Then I have to test the null hypothesis whether mu1 is less than equal to mu2 or mu1 is greater than mu2. This is an example of rat-tailed jet test. Okay. And the test statistic formula which I will use is x1 bar divided by x2 bar, x1 bar minus x2 bar divided by standard error. Okay. So x1 bar is 44, x2 bar is 41. 44 minus 41 is 3 and standard error is 2. Okay. So 3 by 2 is 1.5. Directly I have calculated the value as 1.5. Okay. Difference between two sample means is divided by standard error to find the test statistic. Calculated value comes out to be 1.5. Correct answer is option B. Yes, absolutely correct. Okay. Any doubts? Or we shall move forward. Please tell me, Tanu, if you are still having any doubt or anybody, any student is having any doubt, feel free to ask. Okay. As many number of times as you are not clear, feel free to ask. This F table I will provide to you. Okay. And go through it. Try to solve the test statistic, calculate the test statistic with yourself. Okay. And if still you are having any doubt, feel free to ask me. Okay. Whether in the upcoming session. Okay. You can always ask me. Okay. That is the thing. Yes. Now we shall move forward. Okay. Towards the next part of the session. These were the 10 questions which I wanted to explain you all. Okay. This is over. Now let me go through the Google Colab notebooks. For that particular purpose, first of all, I'll connect to a runtime. Okay, let me minimize this somewhat. Okay, it can't be. Let me connect to a runtime. Okay, then I'll try to run all the cells one by one. Okay, Yes. Now you try to see if we assume that a sample of 30 milk carton provides a sample mean of 505 ml. Okay. Population standard deviation is believed to be 10 ml. Okay. So you have to perform a hypothesis test at zero point zero 0.03 level of significance. Alpha is 0.03. That the population mean 500 ml that the population mean is 500 ml, and to determine whether the filling process should continue operating or it should be stopped or corrected. Okay. So using your p-value approach and critical value approach and with confidence interval approach, we will proceed. Okay. So first of all, we will import numpy as np, scipy import as stats. Okay. These from these standard libraries, we will import the all the requisite parameters. Okay. So population parameters are mu. We have calculated. We have declared mu as 500, sigma is 10. Sample statistics is n equal to 30. X bar is 505. Level of significance alpha is 0.03. Okay. I'll run this cell. So null hypothesis I'll formulate as H0 as mu is 500 and H naught. Okay, H0 I have formulated mu as 500 and alternate hypothesis would be mu would be not equal to 500. Okay, that would be my alternate hypothesis. Okay, just 1 second. Yeah, so this would be my null hypothesis. Okay, H0 and HA. Here I have written HA. In the examination, you try to write down the H1. Okay. Now you try to compute the Z value. Okay. So Z is nothing but X bar minus mu divided by sigma under root n. Okay. That particular statement I have written in this particular line and I have printed the value of Z. Okay. Try to see this particular line. I have written this statement and I have printed the value of Z. Okay. When I will do so, I will get the value of Z as 2.7368. Okay. What is the p-value? P-value directly I will compute by this particular statement. Okay. If p-value is less than alpha, we reject the null hypothesis. There is no sufficient uh, statistical evidence to infer that the null hypothesis is true. Okay, that is mean filling quantity is not 500 ml. Okay, so p-value I have calculated 1 minus stats norm CDF. CDF is cumulative distributive function. Okay, cumulative distributive frequency. Okay, of Z, and Z value I have directly computed as this. Okay, so from there I have calculated the p-value. Okay, and then I have printed the p-value and I have computed it by my alpha. Okay, then z alpha by 2. Okay, z alpha by 2 that I will calculate. Okay, that is coming same expression. Okay, but in place of alpha I have written alpha by 2. Okay, then one another example I have taken sample data frame. Okay, pandas data frame I have taken. Okay, A, B, C. Okay, and I have taken it as a list. Okay, and I have associated it with values. Okay, then what I am trying to do, I am trying to perform some random variable events experiments. Okay, outcomes is head and tail, and directly I have made it to choose between head and tail. Okay, this type of example I have just created. Then for dice rolling, you can create an example. Okay, you just try to roll the dice, and in order to perform or in order to provide the variability in the experimental formulation. You can write the expression like this. Okay, this is the thing here. Then mean, mode, and median directly from pandas. You can import pandas as PD. Then you can write down for a given data set how you can print the mean by df.mean, by median as df.median, mode as df.mode, and standard deviation as df.std. Okay, that you can do. Okay, just 1 second. Then for performing your inferential statistics, whether the distribution is normal for your CLT, central limit theorem, as well as for your hypothesis testing, you have to import scipy.stats. You have to import norm, matplotlib dot pyplot. You have to import PLT. Okay. Then mean and standard deviation directly I have provided. Then I have tried to create a random probability density versus value graph. Okay, that I have tried to plot here. Okay, y I have declared as the normal distributive function. Okay, x mean and standard deviation I have provided. Then the probability density versus value curve I have plotted. Okay, not much to explain here. There is not much to explain here. Okay, as well as sample and then t statistic p value and print t statistics p value. Same thing is there. Okay, not much to explain that. Next, we'll move forward to the next notebook. Okay, first of all, I'll connect to a runtime. Yes, about norm and in great detail, what is the formula? Why is it calculated? How is it relevant? We will just cover on. Be thorough with the content which we are providing. You will be explained in much great detail. Okay, in the few of our upcoming lectures. What is norm? How is it calculated? How you can calculate it programmatically, as well as how you can calculate it uh, using pen and paper. Okay, both the things would be explained to you. Why I am not repeating the same thing here? Because I have to cover it in the future lectures. Okay, much in great detail. So have a little bit patience. Okay, otherwise I will. Otherwise we will just see. Okay. We will just see in our later classes, okay, what is norm, how is it calculated in probability, what is the statistical significance, as well as all the other things. Okay. So next is your from this particular another notebook. Okay. I'll run all the cells so that I don't have to individually calculate the value, individually just run these cells. Okay. From SciPy, I have imported stats. Okay, then stats.norm.pdf. Okay, I have just made it as binary function. Okay, taken the values as 0 or 1. Then cumulative distribution function I have formulated CDF. Okay, then calculated 1 minus norm. Okay, then Z alpha for a lower tail t-test or for a upper tail t-test I have directly calculated. Okay, for mu equal to 30, sigma equal to 10, n equal to 30, x bar equal to 32, alpha equal to 0.05, these values, computed the z value, then stats.norm.cdf of z, okay, that value I have calculated, p value I have calculated, then printed the p value, okay. In the same p value approach, I am trying to explain here. Okay, Z alpha you will calculate. If Z alpha is greater than Z, we will not reject the null hypothesis, otherwise we will reject the null hypothesis. And the same example, okay, I have done here, not much to explain here. Okay, now just 1 second, I'll quickly go through your doubts you are having. I'll explain you each and everything. Just 1 second. Yeah. What is norm? Why it is used? I'll try to explain you in brief. Other and rest is, sir, can you explain what is NO in simple words? Yes, I'll just go through it. Just 1 second. Here at the end, I'll try to just explain you. Okay. See, for example, if we are having a data vector, okay, data vector is like your x1, okay, then another data variables are provided x2 and plus and so on up to xn, okay. Then norm is not only there in statistics and uh, not only present in statistics. First of all, you have to understand what is the norm of a data vector. Okay, so data vector for data vectors means the vectors which are indisparrately sparse in different directions. Okay, we tend to calculate the L2 norm. L2 norm is the first type of norm, which is nothing but square sum of all the individual vectors and under root of that. It will measure the overall magnitude of observation. Okay, it is closely related to sum of the squares. Okay, which is fundamental in case of your variation, regression, ANOVA. Okay, so that is the first type of norm. Okay, squared norm. It is the basis of variance, least square estimation, as well as your residual analysis. Okay, squared norm means nothing but individual sum of squares. Means here you will do x1 square, you will do x2 square, then you will add all the individual squares and then you will take the under root. That is your first type of norm, that is your L2 norm. Okay. Then in case of linear regression also, there is particularly first another type of norm which is OLS. In case of your ordinary least square regression, you try to minimize the modulus of y minus x times beta. Okay, that expression whole square. This you try to just minimize. Okay, in those case is your y is the response vector, x is your design matrix, and beta is your parameter vector. Okay. This is this particular norm will try to measure the residual error magnitude. This particular concept will be taught to you in your machine learning basic courses. What is OLS, what is ordinary least square regression, and why we are measuring this particular norm. Okay. Then when you will try to measure the Euclidean distance between 2 points, that is under root of x2 minus x1 whole square, y2 minus y1 whole square. Okay, sum of these two values and then under root. Okay, then you will try to provide for your k-means clustering or for your multivariate analysis or for your outlier detection, you will try to calculate this particular Euclidean distance, then you will try to minimize. Okay, you try to minimize this particular expression for getting the maximum clusters. Okay, so that is another type of norm. In your statistics, one another norm is there, that is L1 norm. Okay, L1 norm is nothing but just the minimal value or the summation value of individual state vectors. Okay, individual x size, and I have taken the mod. Okay, and then I have summed all the values. This is used in your regression, in your lasso regression, in your sparse modeling. Okay, this one is L1 now. It is less sensitive as compared to less sensitive in responsive to your outliers as compared to your L2 norm. Okay, so these are different types of norms. What is the statistical significance? I tried to explain you. Okay, norm, you don't try to confuse it with normal distribution. Normal distribution is a probability model. Norm is the deterministic measure of the size. Okay. Either you are going for under root x1 square plus x2 square plus xn square plus and so on up to xn square, or you are going for L1 norm, which is summation of mods of xi's. Okay. Don't try to confuse it with the normal distribution. They are totally different things. Okay. Why norms are used in statistics? In order to quantify the error magnitude, measure the distance between two different data points. Okay. Formulate the optimization problems, define the convergence of estimators, or for your regular statistic modeling. Okay. Norm is basically a mathematical tool. Okay, to measure the size of the vectors for data error parameter, and it underlies the core procedures such as least square estimation, clustering, and regularization. Okay, so this was the information regarding your norms. Okay. Then what was the another question? Explain ANOVA in simple terms. Okay. I'll try to explain ANOVA in simple and complex both the terms. Okay. Very, very important for you as a student to understand, because if you don't understand at this point of time, then in future also you won't be in a position to apply those tests of significance when it comes to real world experimental data. In those particular cases, it is very, very essential to apply the correct test of significance and prove what is the significance of the actual parameters. Okay, this is very, very important for you to understand which test you have to apply in which situation. That is why a brief summary table I have created, and I have tried to provide you along with the requisite explanation. If you want, I can provide, but be very thorough with it, that in which particular case you will apply which type of test. Okay. ANOVA, first of all, you try to understand it is analysis of variance. Okay. It's a parametric test, inferential procedure, whether it is used to test means of three or more populations. Okay. Three or more populations, whether they are statistically equal or not. Okay. This is regarding your ANOVA, means analysis of variances. Okay. In which particular cases you will use? In those particular cases in which we are dealing with three or more populations. Okay, three or more populations, whether they are statistically equal, you will use the concept of ANOVA, analysis of variance. It operates by decomposing total variability into systematic and random components. Okay, first First of all, it was introduced by R.A. Fisher. R.A. Fisher, Ronald A. Fisher. He is also known as father of statistics. Okay. So instead of comparing your multiple means using repeated t-tests, okay, which will inflate your type 1 error, okay, you will go for ANOVA testing. Okay. In case of your ANOVA testing, what you will formulate, you will formulate the null hypothesis as well as the alternate hypothesis. Null hypothesis would be nothing but mu1 is mu1 is equal to mu2, which is equal to mu3 plus and so on, all are equal. And your alternate hypothesis HA will be at least one of the mean differs. Okay. It does this by comparing the variance between groups to variance within groups. If between group variability is large relative to within group variability, group means are likely to be equal. That is the concept. Okay. So within the group variability, you have to compare along with all the variability which persists in the entire group. Okay. So suppose K is the number of groups and Ni is the sample size of the groups. Okay. Here I will write it down. K is the number of groups. Okay. My pointer is not showing. Yeah, pointer is showing now. K is the number of groups. Ni is the sample size in the group. Okay. And xi is the group mean and x bar is the grand mean. Okay. So the total variability SST, okay, SST would be nothing but summation xij minus x bar whole square. Okay, that is the total variability. It will be decomposed into the individual variabilities of the groups. That is SSB plus SSW. Okay, SSB, okay, it would be the between group sum of squares. Okay, it would be summation ni xi minus ni xi bar minus x bars. It will try to measure what is the treatment effect. And SSW is nothing but your within group sum of squares. That is summation xij minus x bar whole square. It will try to measure the random error. Now, what is your F statistic? For every statistic, there will be a test. Okay. So that would be nothing but the value of MSB divided by MSW. Okay, mean square. Okay, that value you try to put here and then you try to formulate H0 whether you will try to reject the F0 with the test statistic or accept the H0 or the null hypothesis. That depends on the value of the test statistic, whether it will be greater or less at that particular level of significance. The value of test statistic you have to calculate and compare with the standard table, and on the basis of that comparison you will try to formulate what would be your value of statistic, whether you will be in a position to accept the null hypothesis or you will be in a position to reject the null hypothesis. That will only depend on that. Okay. So ANOVA in general formula you can remember, as well as looking the F value in the table that I have demonstrated in front of you, that you can remember, as well as the formula you can remember. And the central idea is this one, that it is used to compare the means in three different means. Okay, three or more than three different means. In less than three means, your work would be mostly done by T and Z test. Okay, that you try to understand. Now, what are the different types of ANOVA? Types of ANOVA means one-way ANOVA and two-way ANOVA. Okay, one-way ANOVA is one categorical factor. For example, your teaching method. Two-factor ANOVA, it can test your main effects as well as your interaction factors also. Okay, repeated measure ANOVA is also there. Same subjects are repeated to multiple times, then you do multiple times ANOVA. Now, another thing is this MANOVA is the new term. Okay, this is multivariate extension or multi-dependent variable type of ANOVA is also existent. Okay, this you should be very aware. Why ANOVA is used? It is used to measure multiple means simultaneously, comparing comparing multiple means simultaneously means more than three or more than three. Okay, for controlling your type 1 error, because if you use t-test within the errors within different sample mean groups, it will increase your type 1 error. Okay. Then forming the foundation of regression modeling, yes, ANOVA is used for that and for your experimental design in various fields. In your agriculture, medicine, psychology, engineering, every other case, your ANOVA is used. Okay. Basic idea along with the formula, everything is there. Okay, I have covered it. I hope that ANOVA is much more clear to you. Okay. If still you are having any doubt, feel free to ask me. Okay. Okay. Anybody, any more doubts? Anything you want to ask, feel free to ask. Okay. And after the class is over, please download all the material which I am sharing. Okay. Yeah, one more thing. Link I haven't shared. I'll just share it. Just 1 second. I will share the link. This is the link to the Google spreadsheet. Please share, please save it and share with your peers also. Okay. Whomsoever are there, please share it with them. Okay. So that you would be in a certain position to get all the facilities. Okay, very simple. See, some of the students were having doubts, sir, how we can use the material which you are sharing. Just watch my screen. Okay, just have to click in the link which I have shared with you. Okay, after that, for watching the YouTube video recordings, see here week-wise the content has been shared. And for the notes PDF as well as the Google Colab notebooks, just click on the link here. Okay. Then till week 4 I have shared with you. Week 5 I will share with you today by today itself. Go through it. Then just download this particular IPNB PYNB notebook. From here, click on three dots, then go to download. Okay. Just download this particular notebook on your local system. After downloading, okay, go to Colab, and from here, some they have changed the interface. Then you go to notebooks. Okay, just 1 second. First of all, you write down Colab. You go to Google Colab. Okay, then you go to notebooks. Okay, what has happened? Okay, oh, I don't know whether there is a problem of interface or they've changed the interface. Yeah, this particular link is appearing here. Go to upload. Okay, then you browse and you try to give the location of the particular file. Okay, where you have downloaded. Then you change different types of parameters, try to play with the parameters and see that by changing which parameter, what value you are getting in the output. Okay, and don't ask me for the access of the notebooks. Okay, I cannot provide the access to more than 100 students. Okay, if I provide, then the original copy will be lost. Okay, so that is not possible for me. Okay, don't try to ask me for the access. Download it, keep a copy with you. Okay, then change it as many number of times as you want. Okay, that is the thing. Yes, one more question was there. Yeah, recording link is here in this only. Do we get Python coding for final exam? Yes, you may get. Please contact the NPTEL team. They will be in a position to answer you what would be the examination pattern, okay, as well as how and which type of question you would be getting in the examination. Okay, coding questions you may get because in the lectures we have covered it. Okay, which is done by you is enough for exam. Yes, it is more than enough. See, for the examination, the content which I am sharing with you as well as the video recordings which are pre-recorded lectures are more than enough for you all. Okay. Attend these two live interactive sessions. Before these live interactive sessions, go through the previous week's content. Okay. Try to go through all the content. Try to revise each and everything. Okay. As well as solve the assignment. This entire exercise is more than enough for the examination. Okay. Yes, are the research papers added are also important. Yes, you may go through them. Okay. You not need not to memorize each and everything, but you may go through the research papers also. That is why I have given to you. Okay. Sir, in the hypothesis testing, when do we prefer using p-value approach instead of critical value approach? Does this change the final decision? This I can explain to you with the help of examples. Okay. Whether in case of hypothesis testing, in which particular scenario you will go for which type of testing. Just give me a minute. I will share the screen or I'll create an example. Then I will be in a position to explain you. Okay. Just one second. Yes. In case of your hypothesis testing, whether you are going for p-value approach or you are going for critical value approach, mathematically they are equivalent. Okay. Under a fixed level of alpha means significance level, if you have kept it constant, then there is no mathematical difference. Okay. Preference is only practical and it will affect your interpretation. Okay. And whether how you are reporting the outcomes of the experiment. Okay. That will only change. So when in which particular case you will go for p-value approach. When you want the strength of the evidence, not just a decision. Okay. The critical value method will give a binary outcome. Okay. It will reject null hypothesis or not reject the null hypothesis. But your p-value approach, what it will try to provide you, it will provide you the probability of observing data as extreme as under H0. Okay. So it will try to give you a probability. Okay. It will give you a p-value, p equal to 0.049 or p equal to 0.00001. Okay. Both the p-values at a significance level of alpha equal to 0.005, they will reject. Okay. Both will reject at alpha equal to 0.05, but evidential strength is very, very different. At 0.049, the evidential strength is large, and at p equal to 0.00001, the evidential strength is very low. Okay. So this is very, very important in case of your medical research as well as in your high impact research studies or meta-analysis. Okay. When your alpha may vary or it is not fixed in advance, if the significance level is not pre-specified, pay value will allow you the flexibility. Okay. So decision at alpha equal to zero point 0.1, decision at alpha equal to 0.05, decision at alpha equal to 0.01. Okay, these are the decisions that are being made at a certain level of significance. Okay, but one computed p-value will work for all. It will try to critically analyze that what is the significance of your results and why you are accepting or rejecting a particular hypothesis. Okay, so your outcome will not be binary. Okay, it won't be limited to a binary when you are going for when you are going for the p-value approach. But when you are going for the critical value approach, your outcome will be binary. Mathematically, they are more than they are equivalent only. Okay, this is the thing. If you are going for statistical analysis using any software, R, SPSS, Python, okay, they will automatically report the test statistic. They will report the p-value. They will report the CIs, confidence intervals. They will rarely emphasize on the critical values. Okay, so p-value reporting is standard in applied statistics. Okay, in case of your research publications, also t-value, p-value, and rejecting or accepting a particular hypothesis, p-values more largely used. Okay, more frequently and more largely used as well as reported. Okay, this is the thing. So this is regarding your critical value or p-value approach. Okay, it's depends on which what is the type of the application. Okay, what is the type of the application? Whether you will go for critical value method or you will go for p-value method. Okay, it depends on the type of application. That is a one line conclusion. Okay, is it clear or still any doubt is there? Any doubt is there, feel free to ask me. Okay, okay, okay. If it is clear, then thank you all for joining the session. Okay. How do statistical concepts like CDF and PPF practically help in decision-making problems in data analysis? Okay, these all the concepts. First of all, you have to see a particular practical problem. Then you have to analyze a particular practical problem. Then you have to formulate a decision. Okay, formulating a decision-making problem is typically challenging. First of all, you are seeing some simple examples that I have applied ANOVA here, MANOVA here, T statistics, Z statistics that we have seen. Okay. In case of your typical data analytics problem, they won't be that much simple. So in those particular cases, we go for multiple testing. Okay. We try to go for first of all testing with T, then Z, then MANOVA, ANOVA. Slowly and gradually you try to proceed. Okay. Practically, in decision-making problems in analytics, you are just thinking that sir, population mean is different than the sample mean. What you exactly infer about it, okay, that you will learn more and more when you will go through the particular course, okay, design of experiments, DOE. In that particular course, you would be taught that how experiments are designed and how different experiments are conducted and how we are able to predict the influence of various conditions, various environmental parameters, and various conditions which are directly or indirectly influencing our experiment. Okay. So when you will be conducting an experiment, there would be hundreds of variables which would be affecting the outcome of the experiment directly or indirectly. Okay, so either you have to eliminate some of the parameters or you have to include those the influence of those particular parameters in your experiment. In that particular case, the decision would be directly affected by your test statistic and what is your direct outcome. Okay, outcome would be mainly governed how you are performing this statistics analysis of those parameters, those independent parameters. You have to perform the statistic, you have to conduct the analysis, then you will be in a position to tell that whether I have to eliminate the influence of that particular parameter on my experiment, or you have to include the influence of that particular parameter in the experiment. Okay, that is the thing. So don't worry much about the practical significance. Slowly and gradually, you will learn more about it. Okay, that is the thing. Okay, any further doubts? Anything? If you are not having any doubts, then you can kindly leave. Okay, and rest all the students do join the session next week, same time, same link. Okay, and thank you all for joining the session. I'll just be here for a few more minutes. I'll explain you your doubts. Sir, why do we standardize data before applying some statistical method? Okay, to reduce the noise. Okay, in all of the rest of all the cases, okay, there will be noise infused in the experimental data. Okay, so standardization is a general procedure in which you are subtracting all the observations, okay, with a particular mean, mode, median. Why you are doing it? To to reduce or to eliminate the effect of the noise on the entire data set. Okay, so applying before applying the test statistic, your values would be in a certain range. Okay, the lower bound and the upper bound would be set in a particular range. That is why you will when you will apply the test statistic, you will also get the values in a certain specified range. Okay, these F table I have showed you in previous class. I have talked about the T table, Z table. Okay, those tables have been created for a certain bound of observations, for certain bound of X Y combinations. So you would be able to statistically verify the influence of parameters if and only if your output would be in certain range. Okay, so that is why we go for the process of standardization. Okay, and thank you everyone for joining the session. Whomsoever are writing, thank you. Okay, thank you so much for joining the session. Okay, do join the session next week, same time, same link. Okay, thank you all. Have a great day. Okay, Jevasti, if you are not left with any more doubts or anybody having any doubts, then I can conclude the session. Okay. Do join the session next week, same time, same link. Okay. And ask as many as number of questions. Okay. There is no harm. And I'll write down my mail ID also. If anybody wants to continue the discussion, we can go there. Okay. Sir, does increasing sample size always make our results more reliable? No, it is not always true. Okay. Increasing the sample size will not always make your result more reliable. In some of the cases, it may make, okay, but in most of it, it is not like a general statement, okay. So this statement is it cannot be statistically verified, okay. That increasing sample size will always make our the results more reliable. It is not a statistical statement to make. That is the thing. Please do contact the NPTEL team regarding how much question will come in the examination, what will the pattern of the examination. They will be in a better position to tell you. Okay, I am the PMRFTA for this particular course. I have to clear your doubts. Okay, and uh, do some live exercises with you. Okay, so that you are able to gain some confidence. Okay, that is my particular duty. Another set of TAs is there who have designed the content, and who have designed the PowerPoint which the instructor is using. So they'll be in a position to tell you that what will be the pattern of the examination and how you would be able to solve those questions. Okay. What is the practical difference between PDF and CDF? Okay. That I'll explain you. Don't worry. Just one second. PDF, first of all, you try to understand PDF is nothing but your probability density function. Okay. It will lie between 0 to 1. Okay. So at 0, if PDF is 0, the value of PDF is 0 means the probability of happening of that event is 0. If it is 1, then it is a sure event. Okay. In case of your cumulative distribution function, it is nothing but your definite integral from minus infinity to plus infinity. In case of your PDF, it was from a particular interval a to b. And in case of your CDF, it would be from minus infinity to plus infinity. Okay. It would be a non-decreasing function. It will also range from 0 to 1. It would be right continuous. Okay. So if you try to see, first of all, what it is trying to represent. PDF will be representing the density at a particular point. CDF at particular point would be representing the accumulated probability. Okay. So whether it will give the probability directly in case of your PDF, yes, it will give me the probability. It will not give me the probability directly. Okay. But in case of your CDF, yes, it will give you the probability directly. Okay. This is another difference. PDF will not give you the probability directly. Okay. CDF will give you the probability directly. PDF, what is it is used for? It is used for understanding shape and likelihood of the regions. Okay. CDF is used for computing the probabilities. What is the interpretation? That is the practical significance which you want to learn. PDF is the relative likelihood of happening of that event. Whereas the CDF it in itself is the actual probability. Okay. In case of your visualization, PDF is generally a bell-shaped curve or a density curve. Whether when it comes to your CDF, it is generally S-shaped curve like this. Okay. So when to use PDF for understanding the distribution shape, for skewness, for modality, for tail behavior, for your maximum likelihood estimation. Okay. Likelihood functions use the PDF, okay, comparing the model fit for kernel density estimation. When you will use the CDF for calculating the probabilities, okay, directly integrating the expression of the PDF from 0 to that particular point. Okay, inverse of CDF will give you the median 95th percentile value at risk. Okay, this is the example. PDF will tell you where spending is most concentrated. And CDF will exactly tell you what fraction of customers they are spending below a particular value, suppose 5,000 or 10,000. Okay, that is the difference between PDF and CDF. PDF is mostly local behavior, CDF is your global parameter, global behavior. Okay, yes. Any more things? Whether our model assumes are exactly satisfied in the real data sets that you will be able to tell when you will perform the test statistic. There is no another method that whether your model assumption are actually satisfied in real data sets or not. Okay. You just have to go for the test statistic. Then you have to calculate and then you have to formulate the null hypothesis. Either you reject it or accept it. Okay, null hypothesis and the alternate hypothesis. After performing the test of significance only, you will be in a position to tell that your uh, model assumptions are actually satisfied in real data sets or not. Okay, that is the thing. Tanu, I think you would be able to hear me. There would might be some breakage, but it won't be like that. It won't be a complete blank because I think I am receiving 5G signals here. Okay. Any more thing? Anything? Anybody? Okay. 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 Thank you so much for joining the session once again. Okay. Do join the session next week, same time, same link, and ask as many doubts as possible. Okay. Clarify all your concepts. And if you are having any problem in any of the concepts, I can tell you that. Okay. Do join the session next week, same time, same link. Okay. Use the resources judiciously. Try to be as interactive as possible. Okay. Thank you. Thank you all for joining the session. I'm ending the call for you all. Okay. Thank you.